Hello, hello. Welcome to the last lecture of Chapter 5. So we're going to continue on with our germicidal chemicals and talk about metal compounds. So there are different types of metals that can be used that can control microbial growth. One of the common metals is silver. So silver is used in different creams and bandages. They use silver nitrate drops in eyes. They used to use silver nitrate drops in eyes, I should say, to protect infants from infections in their eyes that could cause blindness. Now they use antibiotic drops, so that's a little bit safer. So the use of metals can lead to different problems, so they are very regulated. One of the problems that can occur with heavy use of metals, if you're using mercury, copper, silver, is a disorder known as Argyria. This is an irreversible condition, and it causes your skin to turn a bluish color. So this is a normal hand. This is a hand of an individual that has Argyria. Here's the face of an individual that has Argyria. So this is irreversible, and it's just accumulation of silver under the skin. The next germicidal chemical is ozone. Ozone is a very unstable form of oxygen, so it decomposes very rapidly, but it does have a very powerful ability to oxidize materials. So we could use ozone to treat drinking water and wastewater as an alternative to chlorine, where then you don't have to worry about those byproducts being formed, and the oocysts and cysts may not be able to grow in the presence of this powerful oxidizer. I believe this is our last one. I could be wrong, but we're going to talk about our peroxygens. So these also are powerful oxidizers. They don't produce any residue. They're very biodegradable. They're not very toxic. So relatively, they're safe. So how they work is peroxygens will break down the cell structures, and so they bind to the plasma membrane of cells, or they bind to DNA, and they basically act as free radicals, and they damage and destroy cells. So what in aerobic cells, we produce an enzyme known as catalase that breaks down the peroxygens, like hydrogen peroxide is the example, into water and oxygen, which is not nearly as dangerous. But if you don't have this enzyme, then you're not going to be able to do this process, and you're going to end up dying. So it is effective against certain species, but not against all species. Another example of a peroxygen is peracetic acid, which is much more potent than hydrogen peroxide, which our cells can take care of. So peracetic acid can sterilize in less than an hour, but so human cells can't break peracetic acid down, just FYI. And then we have phenols. I did not, so I was close, but I forgot about our phenols. Phenols are one of the earliest disinfectants. They can be irritating to the skin, and they can have an unpleasant odor, though I think they have changed that a lot. They work by damaging the cytoplasmic membrane. Phenols kill vegetative cells and some viruses, but not all. They have a reasonable cost, and we can store them for longer periods. Examples would be hexachlorophene and triclosan. Most people have heard of triclosan because it's been found in so many items that the FDA is now limiting the use of triclosan. So I just picked this image off of Google Images. One of the most famous bisphenols is Lysol. Lysol is used and disrupts cell membranes, inhibiting fatty acid synthesis, and it can eliminate lots of viruses as well. So viruses and bacteria, very effective. And in general, they have changed the smell so that it's not so irritating. I really did lie, didn't I? I told you that the last one, but I had two left. Quats. So quaternary ammonium compounds, these are your detergents that are effective at helping to emulsify materials. So think about lotion or soaps and detergents that you use in washing dishes, washing your clothes, washing your hands. These are what we're using. The positive charge of the quat is attracted to the negative charge of cells, and so it helps us to break down the cell itself, and it also helps to mechanically remove the cells. For enveloped viruses, again, the negative charge of the virus envelope is going to be attractive to those positive quats, and so it's going to also inactivate those. So this is a list of the different chemicals that we talked about, and oh, sorry, and my goodness, sorry, and it talks about the characteristics as well as the uses for each of these. The last thing we're going to talk about in this lecture then is chemical preservation of foods. So we use chemical preservation to prevent the grow or to slow the grow and extend shelf life. So there are certain chemicals that we add to foods like sorbic acid, propionic acid, nitrates and nitrites can be used. They can be added to meats, and in general they don't affect the flavor as much, but they do inhibit the growth of bacteria and even some endospores. Of course, everybody knows about low temperature storage, so we typically store any perishable foods in our refrigerator or the freezer. So the refrigerator inhibits growth of pathogens and spoilage organisms. That doesn't mean that they're not going to grow. If you leave anything in the fridge for a long enough period, then they will still spoil. Freezing will stop microbial growth in general, but that doesn't mean that they have been killed. So as soon as they are taken out of the freezer and the food thaws out, microbes can potentially survive, and they will then start replicating again. And then many mechanisms for preservation are via salting or adding sugar. So what this does is it dehydrates the material. Bacteria need to have water. So if they're in a very hypertonic environment, all of their water will be sucked out, and that's what high salt environments are. They're very hypertonic to the cells, but some cells can grow in high salt environments. So example would be Staph aureus. Staphylococcus aureus is a halotolerant species, and there are some cells that need that salt, but we don't tend to worry about those. They're not disease causers. And finally, we have lyophilization, which is freeze drying. So this is used to, or in production of coffee and meats and dried milk, powdered milk. in some vegetables. Drying in this form does stop microbial growth, but it doesn't kill. And so if you take dried eggs, eat dried eggs, there have been cases of salmonellosis that have occurred through that. And that is the end of our lecture. So I'm going to stop here. I'll post the video and I'll start on the next videos shortly. Have a great day. Bye.